Fantastic. Good morning, everyone who has, you're attending from, I'm from Melbourne, actually, which is about 14 hours ahead of the Toronto time. So good evening to those who are attending or joining from this side, this part of the world. Okay, today we shall talk about a new model of computing called prompt response computing. We came up with this idea at Keybyte Systems in Melbourne. I work here as with a lead with a small group of software developers at Keybyte Systems in Melbourne. We did not come up with this new model of computing as such because of any philosophical satisfaction about it. But this is has been created to address some of our, very practical needs of software development and by the problems we face as developers, by our clients as well as our stakeholders as well. So we'll proceed with this. Today, I put the summary of PnR computing paper that was published in this conference. The title of the paper is PnR Cloud Computing, Intentions and Context. We shall see that PnR computing means a transformation of PnR, not integers and numbers or vectors and matrices and so on. But the PnR is just a prompt and response and with some nuance into it, and can be represented as a pure JSON object. And just like, for example, what we see on the screen, here we are solely working on the question answer pairs, but the operators are intentions, objects, and design chunks. I shall explain these terms, but taking our conference morning as the scenario, if we have to transform the question, how is the conference, we shall use the operators, three kinds of operators. One is for our intention. The second is the paper as an object, kind of, and the third is importantly referenced as the design chunk, which is in our case, what we are going through now is basically the design chunk, and it can be anything. It can represent anything that we can imagine that can what can happen now. Right. So that's what we are talking about, the transforms of the PnR rather. So, some of you may be wondering, how can that kind of design chunk concept relate to our computation model? We shall go into steps by developing quickly the concepts required. Firstly, we work in a domain which we define as a collection of limited number of PnR conceived, which we define as a collection of limited number of preconceived PnR, basically. These phrases are unique. The phrase we are referring to, that, especially the prompt one, the prompt is unique in the domain, but the responses and the trivalence they carry, that can change as we progress with the computation. The change of the responses and the trivalence of the prompts happens with the help of three kinds of entities. They are the objects and the intentions and design chunks, as we referred. In the computation model, each of these are represented by a unique phrase of corresponding category. So we do have a collection of, that's what the database kind of signature there. We have a collection of the design chunks, collection of the objects, and collection of intentions in the database as phrases, and they're unique for the domain. So what we see on the screen is a 5 tuple starting with a design chunk, then there's an intention. It emits an intention, and that intention is received by an object, and that object reflects another intention, but there's a mapping happening there. So it could be the same intention or another intention, or even a multiple intention as well, actually. But the point is that these intentions are carrying some set of PnRs. And again, the PnRs are from that domain that we are talking about. And so then that finally that intention is absorbed by another design chunk. So that's a general concept of that computation going on with the 5 tuple. So yeah, the object has basically is a mapper of those specific pair of intentions that carries the PnRs. So let's just look into the design chunk a bit more in depth. Like it can be actually any of those like eight or nine things that I've listed there, can be more there as well. But I think the most importantly, the human actions is actually treated as a design chunk. And user actions in the context of the design chunk can be a design chunk, or is part of a design chunk rather. And the design chunk can be nested actually. A design chunk can have other design chunks, but there is some restriction on that. It's just not just pure nesting. It has to be something called CPUX, which is the common path of understanding and execution, but we'll come to that later. So conceptually, one design chunk can reside with another design chunk, but there is some mechanism for that. So that finally, if we can compare the design chunks with like, I think we have missed one slide maybe here. Okay, so how do these design chunks communicate actually? Like if they are it can be code, it can be any media, any sound, any behavior of code, as well as just static content as well. So how do they communicate? So if you compare the traditional like like you may wonder what that indication in direction of objects intentions as like intermediary of those design chunks that we talked about, and what is the short answer? I mean, what is the role of that in our communication of the design chunks? The short answer is to get a unique unique address of any design chunk occurrence in an execution context, in execution space defined by our domain. So, but there are some intrinsic value to it, which makes the computation facility as a cognitive journey rather. The model, the parallels how we as humans interact with our surroundings and objects, and it parallels like how we interact basically with our objects around us. Objects are after all something that's static, that has some state, and we question, comment, relate to that state. What happens in a summer hot day? You are trying to find a spot to sit and have your lunch in the open, and we naturally engage with some sort of conversation with that rock and find out if it is too hot by sending our intention and receiving a feedback, which makes us decide not not to sit on if it is too hot. So that conversation is going on, and in some way that this model of communication between the design chunk is following that model actually. So yeah, so that leads to the comparison of the when you're talking about the software communication, I'm sure we developer have set up many mechanisms of software components by which the software components interact, communicate with each other. As you can see, none of those characteristics of those, like the previous mechanism, quite match with anything that what design chunk offers. But this is the beauty of that abstraction. You can bring in functionalities at that level that can accommodate and almost anything else designed to do that something. So in the PnR computing, like CPUX is a common path of understanding and execution with the granularity of the design chunk. So you can reach at any design chunk with a unique address during execution time. So I know the design chunk allow me to make a square also if I can sequence a few squares to make a house shape. But what will be the process for doing that? We can make a design chunk that can place the square in a certain position of the coordinates. I can make two design chunks that work together by mapping one set of PnR to another, and then come up with a sequence that makes the house. That is a CPUX to make a house using intentions and PnRs. The actions of the design chunk has to be absorbed by another design chunk until my state is reached as an object. That's why the 5 tuple is the smallest unit of computation in PnR. So if you take an application very simplistic application scenario where suppose we have got a very an application launch where the user is offered some drinks, what drink he selects, and he gets a drink. So in this scenario, like we'll get a certain screen like that. We choose a hot option, we get a hot drink. We can select the hot drink. And if we choose the, we can get the cold drink and so on, right? And so what is happening here is actually the user is actually taking part in a loop, which is called space loop. And there are several other loops going on with the server, which are each of them is like if you imagine all those HTML, like the scenario we just went through, allow 2 CPUX to act and share data. One is the space loop where the user action is one of the design chunks. So what we are doing here is we are considering each of those HTML JavaScript page as one design chunk. The others are so each of those is a standalone design chunk. What is happening is the CPUX that serves a particular design chunk and a particular screen component, a mix of JavaScript and HTML, take part and there's a loop there, and what we are doing there is in this case, I mean, it can be done in several ways, but there's a loop there, server-side events, and any CPUX loop is referred to as an intention loop. And so in this case, we have got the CPUX that occurs multiple loops is referred to as the, I mean, that all the CPUX are taking part in that space loop that is sitting on the client side, really. And the user is actually part of that space loop. But we can go a bit more detail on that. Like we'll have a proper site with the the code sample and everything there. But for this discussion, we'll just keep it. All right, so that's the basic concepts of computation scopes in PnR. Like the loops actually define the scope. The loops in CPUX defines the scope of the computation. As such, the design chunk is a closed scope. But the way it emits and absorbs the intentions allow them to flow in the PnR and flow out the PnR to the immediate outer scope. So there's a standard flow in, flow out, and also there's a concept of gatekeeper and visitor, which is the gatekeeper is the PnR set by the design chunk, which allows it to be scheduled for an execution in a loop. So in general, any app, there can be two loops. One is across CPUX, and another is a bunch of CPUX working together, which is the space loop here to coordinate the different CPUX. So intention space is a framework really, which brings together all the tools that you need to work productively with the PnR computation module. In the Keybyte systems, we are building a platform with all the tools supporting the PnR model of computation and for general use. And as I referred in my previous paper published in the international INJNLC journal, that intention space will be an open source platform where the software component can communicate. I mean, the communication protocol of these software components will be based on the PnR model. Yeah, so coming back to the why the intention space, like as I mentioned before, we worked with multiple technologies over multiple generations, and we do find that there's a chasm between the phases of software development, life cycles, and between work we need to do for multiple custom platforms. So we believe that the intention space platform will help tremendously in that front. Yeah, coming back like there are some architectural patterns that we can build on these the ones we have that the cognitive bridge rather between different phases of the development, and also it allows to communicate the open communication between two apps actually, as like what we look at as app. Several apps can exist in a particular domain as well. But the most importantly, I think that there's a discontinuity in the whatever way we develop software nowadays, or so far we have done last 20, 30 years. Like there is always a chasm between the requirement gathering, like the prototyping, coding, testing. They're all different silos actually. So this intention space will really bridge that properly. And yeah, this is again we have already talked a bit about it. It gives those two those three things, the three layers of scope rather. One is the actual the design chunk itself, which resides within the CPUX, and the intention loop and the space loop. Yeah. So what is the basic strength of the PnR model as such is, I mean, even if you are not using the platform, but still there are some benefits if you can derive from it, or you can use in your own work as well. Like there's something fundamental here actually, which is as I say that at the heart of the computation, whether in machine logic or human-computer interaction, lies the continuous exchange of state and iteration. So we have captured those two things in our model actually, and that makes it so powerful in that way. So every system must maintain this state to reflect its current condition, and every system must loop or iterate to handle dynamic input and changes. These are the foundations of computational design. Yeah, we can talk a bit more about the other benefits we get out of the CPUX concept, that each design chunk is actually has got a unique identity that can be tracked at execution time, and that has got other benefits in the security space. And I think we will skip over it for the time being. And so yeah, that's the gist of it. Look, so basically we are talking about safer and social computing, safer social computing. So intention space does open up a better, healthier internet that can go hand in hand with our AI, with our AI progress, and build a better social, better education network, virtual society rather. But yeah, there are lot to do and around the tool support as well as the scaling. Like as you probably have felt, if you have only 5 or 6 PNRs, is quite that itself is a bit hard to coordinate between different design chunks, how one design chunk change the PNR, and how the other design chunk has to cooperate or incorporate that, or how to design the whole together. But those are the work to be done, and we are building some of the facilities on the cloud platform as well, because without bringing any extra layer on top of like the Kubernetes, we can actually incorporate in the like the PnR computing model inside individual developer, individual component actually. So within a container, it need not sit outside the container. Actually, it can be in the container without really, like even, well, we can always wrap the container in a PnR. That's also possible. But the whole idea is we don't need another middleware to interface between two things, so that when that middleware becomes a problem actually. So that's how we are not, like, our objects doesn't hold any code. The design chunks hold the code, and the design chunk can be anything really. Well, it can be a container, it can be in a React program, a Node.js server, Golang server, whatever. Yeah, something. Thank you, guys.